Alright guys, so today we're going to talk a little bit about slave flashes and how they connect to the various slave controller boards that I market. And the first board is going to be the Slave Blaster board seen here. The Slave Blaster comes pre-wired with your CDS and the PT, and it also comes with a toggle switch for power and a 9-volt snap type connector for your 6-volt power supply. If you want to use one of the battery holders that has the snap connectors on it, or you could take this connector out and just wire up any other battery holder that you have to the connection ports for the power. Now on the Slave Blaster, it actually is programmed for 3 different flashes, single flash, 2 flash, or a 3 flash, and those are selectable through the dip switches at the top. Dip switch 1 on and 2 off would be for a single flash. Dip 1 off and 2 off is for 2 flash, and dip 1 off and 2 on would be for a 3 flash camera, such as the Pentax or Kodaks. Now to connect your slave flash to the Slave Blaster board, you'd simply connect your trigger wire negative to the bottom screw terminal here on the left, trigger positive to the next terminal up, connect your slave flash positive wire to external positive, but you need to solder in this 1 ohm 2 watt resistor to your slave flash positive power wire, and then connect the resistor at the screw terminal, and then your slave flash negative power wire would connect at external negative here on the board. And that's all there is for connecting Slave Flash to the Slave Blaster. All Slave Flash control boards are basically the same. They're just labeled a little bit different on some of them, and the terminal locations are a little bit different. This is the RC Davis slave controller version board, and it is not selectable as far as the flash settings. It has to be ordered pre-programmed for whatever camera you will be using it with. Connections are basically the same as far as slave flash goes. Your slave flash negative power wire would connect to the bottom terminal here on the left, and slave flash positive power would connect to the next terminal up. But like I mentioned before, you need to make sure you install the 1 ohm 2 watt resistor between your power wire and this connection here. Trigger wire connections on this board are on the right, and the bottom screw terminal would be for trigger positive, and the top screw terminal is for trigger negative. The middle screw terminal is not used on this board. And of course your on off switch is here. It's just a latching on and off switch. And then the last slave flash control board that I have is the Flash Backpacker. Now this is not a standalone slave controller. It requires to be used with the Safari camera controller board, so that this makes this an all-in-one camera controller and slave flash controller combined. You would simply connect these 2 boards together using the stackable headers. There's a 6-pin header on one side and an 8-pin header on the other. Line those pins up and slide the boards together. This flash board comes with a PT pre-installed, and it also has the 1 ohm 2 watt resistor already mounted on the board, so you don't have to make that connection between your slave flash positive wire and the board connection. Board connections for this board are starting on the left. You have your slave flash negative wire connection port, slave flash positive wire connection port. Then you would connect your battery power positive wire and battery negative. And on the terminal to the right, the next terminal to the right, you have your trigger positive and then trigger negative. And of course, like I said, the PT is already installed on that board. And that's all there is to that one. Now this board has a dip switch setting on the Safari board, which dip switch 2 would select between 2 flash and 3 flash, depending on which camera you're using it with. 2 off would be for our 2 flash sequence, and 2 on would be for the 3 flash sequence. One thing I really want to recommend is when you start, or once you have your slave flash hacked, I really recommend that you test it out before you start putting it in a build, because if you run into problems and you've already got your slave flash mounted in your board, it's all gooped in, covered, whatever, and then you have problems and you have to tear it out and try to troubleshoot and find out what the problem is. It's best to always test them once you finish with the hack, and then before you install it in your build, I suggest you connect it to whatever slave controller board that you will be using and test that also before you install it in your build. There's lots of variables that can come into play, you know, that can cause problems. Something gets shorted out or whatever, and then you've already got everything in the build and then it doesn't work right. Then you have to take everything back apart and start troubleshooting it from there, and it's just easier to make sure everything is working correctly before you install it in your build, and it will alleviate a lot of problems for you. Another thing I want to talk about a little bit is slave flashes come in different voltages. Most of them that we use are 6-volt slave flashes, and those can be powered with any 4-bay battery terminal or battery holder for AA's or C's or D's, or you could even power it with a 6-volt SLA battery. Now some slave flashes are only rated for 3 volts, so in that case you would want to use something like just a 2-bay battery holder, whether it's AA's, C's, D's, that would provide you with a 3-volt power supply. Now there's also another one that's a little baby slave, the guys are calling it, that is a 1.5 volt, and you would just need a single battery for that one, whether it's a AA, C, or D again. Just depends on what you want to use in there, and of course the larger battery you use, the longer that it will run in the field before you have to change that battery again. Connections for the baby slaves are a little bit different when you go to connecting your power source for that slave flash. Excuse me. Instead of connecting your battery holder, both leads to the slave flash, you would need to connect, say for instance on the 1.5 volt and on the 3 volt also, you would connect your positive power lead from your battery holder to the positive power wire of your slave flash, and then the negative lead from your battery holder would connect in with the 6-volt negative power supply that powers the slave flash board itself. So on the RC Davis board you would actually need to splice into your negative 6-volt negative battery supply here and tie those 2 wires together, you know, to make that connection there. And then on the Slave Blaster board, which actually has a screw terminal down here for the 6-volt power supply, you could just put your 1.5 or 3 volt negative battery wire in with the 6-volt negative battery wire, and that would make that connection there for you. Now on the flash backpacker, it's a little bit different. You can actually wire in any of the Slave Flash's power supplies directly to this board where the connections are marked ground and power. And the reason for that is this flash board does not get power from your slave power source because it is powered by your 4.5 volts that are powering the Safari board. So you can actually go ahead and connect their 1.5 volt or the 3 volt power supply wires, both positive and negative, right here directly to the board where it's marked ground and power, and you're ready to go. Hope I haven't left anything out here. If anybody has any questions on anything, of course you can always shoot me an email or a PM on any of the forums, and I'll be glad to answer them for you. And hopefully these little tips will help you out some when it comes to slave flashes.